Welcome to Sudoku with Jue. My name is Sudoku. Today we have consecutive non-consecutives by Pagito? Pagito. Not sure. Okay. Normal Sudoku rules apply. We have non-consecutive. So cells that are orthogonally adjacent cannot contain consecutive digits. Okay. Cells connected by a pink Renben line form a set of consecutive digits in any order without repeats. We have x sums and v sums. And then we have black Kropkis. Not all x's, v's, or dots are given. All right, let's see what we got. Normal Sudoku rules, 1 to 9 in every row, every column, and every 3 by 3 box. Non-consecutive, so this is orthogonally adjacent. This is diagonally. This is orthogonally. So these digits cannot be these digits cannot be consecutive. These cannot be, these cannot be, these cannot be, these cannot be adjacent. Okay? Then just like Roman numerals, x equals 10 and v equals 5. So these have to equal 5, these have to equal 10, etc., etc. Renben, oh, I skipped over the Renben line. No, that's fine. You guys know what Renben is. So these two have to be consecutive but in any order, just like all of these Renbens. So these can be 1, 2, but it could be 1, 2, 2, 1, 3, 4, 4, 3, 5, 6, 6, 5, etc. And then black Kropki, this has to have a 1 to 2 ratio. So it could be a 2, 4, 4, 8, 3, 6. But it could never be like a 7, because 7 would be either 3.5 or 14, which are not Sudoku digits. All right, let's see what we can do today. All right, I'm going to start with this. So cells that are orthogonally adjacent cannot contain consecutive digits. On a V sum, they can only be 1, 4 or 2, 3, but they can't be 2, 3 because they are orthogonally connected, and 2, 3 are consecutive. So this is going to be a 1, 4. So we know that this is going to be a 6, 9. Same with this, and that's 6, not a 5, 6, 9. This is 1, 4 as well. So, okay, so I'm going to do that one more time over here. 1, 4, and 6, 9. Excuse me. Okay, so if this is a 1, this would have to be a 2, and this would also have to be a 2. So we can place that as a 4, and that's a 2. No, 4 and a 1, sorry. So then this is a 2. Now this 4 can no longer be a 2, but it can be an 8. So this has to be either a 3 or a 5. Oh, hang on. Orthogonally connected. This cannot be a 3 because that is orthogonally connected to a 2. So this is a 5. All right, now let's look at this one. If this was a 9, this would have to be an 8, but it can't be because of that. So we know that this will be a 6. So that's going to be a 4. That'll be a 1. You can put a 1 there. That's a 9. And that'll be a 4. So then I can put 3, 5 there. So this can only be 5 or 7, but we have a 5 there, so we have a 7. There it is. That's going to be a 1, 4, thanks to Sudoku. And this becomes a 6. That's going to be a 2. Now this is a 3, 5. I'm going to pencil mark some 7s there. This is also a 3, 5. 3, 5. Okay, that's a 3, 5 pair already. Love it. Okay, so now this cannot be a 1. So this is either a 2, 4, 8, or a 3, 6. 2, 4, 4, 8, or 3, 6. Cannot be 4 or 8 because we see 4, 8 there, which means if this is a 2, so this can no longer be an 8. Okay. We'll figure that out in a minute. See if we have any more information first. So we can do 9s there. 9 cannot be there. And then 8s are like that. Is this a 7? No, it could be a 3. 1, 2. Okay, so yeah, I'm just going to do 3s there and 5s there. And then that will be a 3 as well. But this actually cannot be a 3, 5 because of this. We have the 3, 5 pair already in the row. Okay. Oh, what's over here? This is going to be a 3, 6, 9. 3, 6, 9. This cannot be a 3. This cannot be a 6. That cannot be a 9. So it's a 3, 6, 9 triple going vertically. So this can no longer be a 3. So that's going to be a 5. This cannot be a 3 or a 9. This is now a 3. Delete. Let's delete that 5. So this is a 9, only option in the box. And then that's a 3, 7, 8 triple. Okay. I am liking this. So 3s have to be down here. So then 3s are up there. All right, figure that out in a minute. So this will be 5, 7, 8. So this 3, 5, 7, 8. Okay. All right. Let's. Okay, so we can place 6s. 6s are here and here. Oh, 6 cannot be here because that's orthogonally connected. Ah, yeah, I forgot about that rule. 6. So now this cannot be a 5. Got to remember that rule. Ah, of course, right over here. That 8 would see both a 7 and a 9. That's impossible. That's a 3, so then we have a 7 here. Oh, my word. I remembered enough to only pencil mark them correctly over here, but come on, guy. Come on. Then we have 5, 8. This cannot be a 5, so that's going to be the 8. That'll be a 5, which means this has to be a 6. So that'll be a 3. That's a 9. Look at this. Look at me go. I can pencil mark the ones up here. What do we need here? We need a 2, 7, 8. 2, 7, 8. This cannot be a 2. Right? Yeah. And that's 7, 8 already, so this is a 2. So that's going to be a 1 or a 3. 3 sees it, so it's a 1. Delete that 2. 7, 8 works there and there. The non-consecutive. Okay. 1, 2. Then this is a 3, 6, 9. 3, 6, 9. This cannot be a 3. 1, 2, 3. This is now 4, 7, 8. Okay. 1. This is 2, 5, 8. 2, 5, 8. This one cannot be a 5. This is an 8. This would be a 7 or a 9. This isn't, so this has to be a 1, 9 pair. Oh, wait a minute. That's a 7, 8 pair over here. So this is now a 1, 5, 7. 1, 5, 7. This cannot be a 5 or a 7 because that's a 6. So this is a 1. That'll be a 2. All right, there we go. Oh, no, not 5, 7. 1, 5, 9. Okay, hang on a minute. I'm going to delete. Okay, hang on. 1, 5, 9. Okay, that was close. Almost made a big mistake. That's not a 5. 9, 8. Okay. Oof. Close one. 1, 5, 9, which puts this as a 2, 7. Yeah. I could have already figured that out. And a 9 sees it. That's a 7. So this is going to be an 8, 7, 8, which puts this as a 2. This can no longer be a 1. It's a 5, 9 pair, which forces that to be a 1. That's a 2. Delete those 2s. 1, 2, 3. This is now a 4, 7. 4, 7. And the only way that this would work is if this is a 6 and a 7. So that's going to be a 4. Only way that works is a 3. This is now a 9, which forces that to be an 8. And that's a 5. Okay, so I can delete the 2s from here, which makes that a 3, 6. So this has to be a 3, 6 pair. Oh, and then the 3 sees that. So this is going to be a 6 and a 3. So this is either 2 or 4, but 4 sees it twice, so that's going to be a 2. Then I can pencil mark 2s up there. 1, 2, 3, 4s. Oh, let's pencil mark some 7s first. And up here while we're at it. Twos are here. This is a 2. This would be a 1 or a 3. Okay. That is possible. 6s. Okay. we know 3s are up here. This cannot be a 3 because if that's a 3, it would have to be a 6 and that sees it. Okay, so that's a 3. That has to be a 2 because the 4 sees it there. Which puts 1 either, 1 is here or here. 2, 3, 4, 1, 1, 5, 7, and 9. 1, okay, this is 7, 9. 1, 7, 9. 5, 9. Okay. Oh, okay. So this one has to be a 4, 8 because the only other possible digits are 1, 2, 3, and 4 sees it. And then right. So yeah. So then this would be an 8, and that's a 4, which puts this as a 5, 9. This cannot be a 5, so that'll be a 9, 5. This has to be an 8. Then this is now 4, 7, 4, and 7. Pencil mark some 4s up here. 1, 2, 3, 4, 5s. Oh, what is this? This is going to be a 6. That's a 6. That's a 7. So this has to be a 5. And then this, excuse me, this is not a 9 and a 1. Pencil marks, excuse me. Oh, my word. 1s. This cannot be a 1 because it would have to see a 2. And that Renban cannot see a 2. Okay. Then I got 2s up here. 8s are like that. 1, 2, 3. Then we need a 4, 7. So we got, that'll be a 7. That's a 4. So that's going to be a 4. Delete that 4. Oh, okay. I can place that 7 now. This is a 9, 5. This has to be a 3 or 5, and it can't see it can't see itself, so it's not a 5. All right. Then we need 1, 2, 3, 4. So 5s are like this. 6 is there. 7. Then 8s are here, and then oh, this is a 9, so that's going to be an 8, 2, 5, and 6, which puts that at, this is a 2, that's not a 2, so this has to be a 3, and that's going to be an 8, which puts this is going to be a 6, finish off the column with a 5, finish off the puzzle with a 9. Yeah, that was good. I think that was the first one I've ever done by Paghetto? I'm not sure how to say the name, but it was very good. Liked it a lot. Great stuff.